All right, you guys, I want to talk to you about solving. We're going to look at lots of different ways to solve a quadratic equation. And the first way we're going to do it, I think, is the simplest. And it's in a special case, but it happens pretty easily and pretty quickly, and it's just called the square root solving technique. So the big idea in this one is to isolate x squared all by itself, and then to take the square root of both sides. It's a fairly natural progression, I think, and so I think you'll find this one not to be that bad a technique. Let's take a look at some examples. So let's look at an example here. Let's look at this guy here. First of all, one of the reasons why this has we use the square root technique is you'll notice in the quadratic equation there is no reference to the linear term of, like, say, it doesn't have like a 2x or a 4x or anything like that. And because of that, when we set this up, when our function equals 0, so we say our function equals 0, x squared minus 9, you'll notice that we can quite easily move the 9 over, leaving us with a very simple little equation. And you recognize what to do here. We would take the square root of both sides. So we would square root this side and square root this side. But a unique thing happens that didn't happen last year or a couple years ago in algebra. Two answers appear. Now the reason two answers appear is because there are two numbers that could work in this case. You could have a 3 or a 3 or a negative 3 would work. Let's go over to the graph for a minute and make sense of this. Our equation is x squared minus 9. You should recognize that this is no right and left and down 9. So it's down here somewhere. So what it's saying to us is that when that parabola is graphed for when it goes through 0, it's going to hit at 3 and it's going to hit at negative 3. That's why we get two answers. Remember, we can always expect two answers unless it's in the one case of the vertex, but we're going to expect two answers. Let's do two more of these. Let's try a second case similar to the last. We see that it's been set to 0, and so we're going to write 0 equals x squared minus 7. Move the 7 to the other side, take the square root of both sides, and we get x equals plus or minus the square root of 7. Now we don't like the square root of 7 necessarily, and we could turn that to a decimal if that would make more sense, but generally we just leave it as the square root of 7. But think about it this way: the square root of 4 is a 2. The square root of 9 is a 3. So the square root of 7 is probably like 2.4 or something like that. So again, if I was to graph it, we'd be to x squared minus 7 down here. And it's telling us it would go like somewhere through here, 2 point something, and it would go through here to negative 2 point something. So this is a very common occurrence. Let's show you one more type of this type of problem. One more just type of an example similar to this. This time we're asking when is the function equal to 44. That's a pretty big number. But it works the same way. We would say 44 equals our function. When does our function equal 44? Over goes the 4 to get 48. I'm going to divide both sides by 3. I get 16 equals x squared. Here's that beautiful experience that we wanted. We wanted this to be all by itself so that we can take the square root of it. And so when we take the square root of both sides, this side and this side, we get plus and minus 4 equals x. So in other words, this is a harder one for us to graph, but our graph, let's see if we can use our previous skills. So it's down 4, so it's down here somewhere. It's got an expansion of 3, so off it goes, takes off. We're asking what's going on out here at 44, and we found out that our x values would be at positive 4 and negative 4. Makes sense that if our axis of symmetry is the y-axis, that these numbers would match exactly each other.